moving on to the second part of this presentation, I am now going to talk about the structure of neural networks in depth. So I briefly touched upon it. You probably heard the term input layer, hidden layers, output layer. Probably heard about neurons and interconnections. But let's talk a little bit more about that. So in a neural network, a neuron, which is the basic unit, is a collection of a set of inputs, a set of weights, and an activation function. The two functions we're going to talk about are sigmoid functions and ReLU functions. So a sigmoid function is basically the activation function. So it's used to quantify the weight or the biases. Weights are essentially just a degree of similarity. So for example, me and perhaps a student also who studied computer science, also probably a male or South Asian, would probably have a higher weight or a higher degree of similarity. Whereas if I was to be compared with a BBA student who's perhaps in a different university, a different country, a different year, we would have a lesser degree of similarity. And why do we use activation functions? Why are sigmoid functions used? Because they can add biases depending on whether neurons are active or inactive. And the second function I mentioned was the ReLU function. This is a linear function which utilizes matrices. So a lot of linear algebra goes into this. And following neurons and the activation functions and all of that, in essence, a network is made up of nodes and layers. As I mentioned earlier, we have, for example, like in this image over here, we have the input layer, we have a hidden layer, and we have an output layer. So anything in between the singular input layer and the singular output layer is just a hidden layer. This could be an arbitrary number. It could be 1, 2, 3, 4, 5. It's arbitrary. So moving back, this is a small image of, well, not small, it's an image of the neural network. So as you can see, there's a data set, and this data set has lots of different information. It has demographics, it has numerical variables, it has categorical variables, it has the date, and in total there are 26 features. So this data holds information pertaining to 26 different features, and number of samples. The sample size could be however much, does not matter. Even the feature size could be however, it does not matter. But in this case, we are using 26 features, and so the input layer has 26 different nodes because one node is responsible for one feature. And after that, here come the hidden layers. Over here, there are 3 hidden layers, and all three of them have activation ReLU functions, and the output layer is where the activation function or the sigmoid function is executed. And these features are all used up. They're all, the information is taken, they're multiplied by a multiple. As I mentioned earlier, they are multiplied by a weight. Where did I go? Yeah, a set of weights. And then they move forward to the next layer, and so on and so forth. And then finally, at the output layer, sigmoid function, the activation function is used to determine a number. And over here in this case, if that number is less than 0.5, the person is deemed to be alive. Whereas if that number is equal to or less than 0.5, that person is deemed to be deceased. So we have data, we can process it, understand the features, understand the connections, the relationship, and we can determine an output and make an informed guess on that data. So here's a video that I found which can really help you understand how a neural network works. But before that, Nalini has asked a question. And Nalini has asked, what if the nodes are, Nalini is asking that what if we use a more wide neural network and a more like horizontally and vertically enlarged network. So essentially, Nalini is asking that what if we add more nodes or if we add more layers? Will the complexity of the neural network increase? And The answer to that is yes. If we have more nodes, and if we have more layers, more hidden layers which process the data, then the complexity of the neural network increases. It will be more, you could say, efficient, more accurate, but it would also consume more energy, more time, and would be more complex as a whole. So thank you, Nani, for the question. I hope that answers it. Moving on to this video that I found. It's a small excerpt of the video. So as you can see, this number 9, this image, well, we don't know it's number 9 yet. The neural network doesn't know what this number is. It just has an image, and each of the pixels has a correlating node in the input there. In this case, there are 784 pixels, and so in the input there are 784 nodes. And each of these nodes are multiplied by a weight, and each of these values depends on the previous layer. So once this is done, it will process, it will make connection, and finally the neural network will determine that number was 9. The same for the number 7 over here, an image, it will get processed, and it will determine that this number is indeed the number 7. Similarly, for the number 2, the nodes go in, multiplied, each layer depends on the layer before, and finally it makes a decision that the number is 2. So yeah, that is essentially how a neural network is structured and how it works.